Hello everyone, we are team SDSLabs from India region and I am Ganav Gupta and I am the captain of this team.
Hi, my name is Adrit Shikhar.
I am Gaurav Ginani.
And I'm Anas Chaudhary.
Let's start by discussing the general binary structure of challenges. All the binaries were unsigned L5 for RISC-V32 architecture. They use SPI to communicate with network using AT command. We cannot emulate them easily because they use network instead of standard IO. We tried emulating by patching these SPI send and receive functions, but we failed in patching the receive function. Though most of the times the compilation was very easy to read, some of the challenges like game.elf were not decompiled right beyond our capacity to repair.
In the challenge burst, we had to input three signed integers. If they satisfied certain conditions, we win the challenge. We set the first integer to most obvious integer and then brute force the second integer so that the third integer doesn't cross the limit of 7 digits posed by the challenge.
The challenge breakfast accepted an integer and a string as an input. It contained a set of strings of length 6. The first string indicated the left shift amount for the set. The second string input was the indices of this set encoded as character. The words at these indices are concentrated and compared to the hard-coded strings. If they match, you win the game. This was solved by splitting the target string in six length strings and finding them in the shuffle set.
The next challenge was flood, in which we were required to give a 4-digit integer as an input. The binary calculated the number of primes between 2 and the number passed, and the loop was required to be executed for at least 10 seconds for the win condition. This was not possible when supplying a normal number, so we employed a flaw in the parsing logic and passed a closed parenthesis as the input. Next up, we were required to send 1000 bytes of garbage data, which we did and got the flag. Last up is quiz. It took in input it took a number corresponding to each of the 9 questions asked by the binary. The binary asked questions along the lines of what is the operation of n1 and n2 modulo n3. N1, N2, N3 are three random 3-digit numbers, and operation is an operation which can be any of some difference product and sum of squares. We wrote a Pontool script as automation was required because the binary required us to answer the questions within 0.1 second, and we did some parsing and sent the results with a delay of 0.05 seconds as the binary misbehaved on instant replies.
The challenge U contained 570 encoded RGB values. It accepted an integer as the index of this array of RGB values and lighted LED according to them. With hints in the binary, we got to know that these are the RGB values of pixel. We tried to convert it into an image and found the key thing colorfully. The challenge recycle was about multi-byte XOR cipher. It encrypts with the same key many English sentences. We had to find the key in the ending to win the challenge. We did it using the standard XOR cipher breaking procedures we use in cryptobus.
The challenge virtual to accept sets of four space-separated integers. The main key points are as follows. Registers can hold value in the range 0 to 3. In contrast to virtual 1, the memory is now an array of 64 characters and uses register values as offset to 60 for the instructions. AC stack points 4 bytes behind the memory. 62 to 63 index of memory is initialized with values 0 to 3. AC stack initialization also fills the memory. A win condition was to assign same values at the index 4, 5, and 62 of the memory. Since AC stack was located 4 bytes behind the memory, we used opcode 7 to assign the value at 8th index of AC stack, which in turn would assign value at the 4th index of the memory. We followed the same procedure for assigning value at the 5th index of memory and hence the win. The challenge pursued accepts a string, hash assets, and compares to a hard-coded value. Also, we are provided with a base64 string which decodes to any find me. The binary has several global variables which contains the parts of a URL. Assembling the parts of a URL gave us a pastebin line, and moving to the pastebin gave us a final key.
These were some of the challenges that we loved. Due to time limit, we couldn't explain everything. Hope you like it. Thank you.